So let me revise whatever we studied still. So our aim is to solve the partial differential equations. In fact, they are the second order partial differential equations. So we started with this part, applications of partial differential equation. Okay. So wave equation, one dimensional heat equation, Laplace equation. Laplace equation is also known as two-dimensional heat equation. Okay. Then we understood what the course outcome, PSU, PO mapping is there. When we studied the Fourier series formulas, till we have not used the Fourier series formulas. Probably in third example, we will use them. Okay. So next we studied the Fourier half range expansion for the period 2 pi and 2L. Then we understood few trigonometric formulas. Hope you remember we used this formula: sine of n pi equal to 0, cos of n pi equal to minus 1 raised to n. So then we started with the one-dimensional wave equation. This is the string whose motion we want to study. Suppose the string is pulled and this is the initial position. This initial position is given in terms of function f of x. So that will be the fourth condition known as functional condition, right? Then this is the position of string at any time t equal to t1. And our aim is to find deflection of the string, u of xt. So conclusion is that u is the dependent variable and it depends upon two independent variable x and t. X is the displacement distance, distance, and t is the time. Okay. Then we have written the wave equation: del square u divided by del t square equal to c square del square u divided by del a square. C square is constant, that cannot be 0. Then boundary conditions, both the ends are fixed. Therefore, u of 0t equal to 0 and u of lt equal to 0. Initial condition, this is functional condition. Usually we write it at the end, and this is the velocity condition. Velocity of the string at the starting is 0, initial velocity, right? This is the most general solution. Then we started with the example where the example was like this: a string is stretched between two ends L apart. Motion is started by displacing the string in the form of u equal to a sine pi x divided by L, from which it is released at the time t equal to 0. So that is the initial condition. Find the displacement from one end. Okay, so one dimensional wave equation is del square u divided by del t square equal to c square del square u divided by del x square. So we are studying x is the only independent variable. Okay, no doubt t is there, but it is time variable. So if I consider y also, then it will be two-dimensional wave equation. If I consider x, y, z, then it will be three-dimensional wave equation. So here we are studying one-dimensional wave equation. These are the two boundary conditions. 1 minute. Sorry. These are the two initial conditions. The order of using the condition should be like this: start with the boundary condition, then velocity condition, then next boundary condition, and then functional condition. This should be the order. Okay. So we started it, we considered the most general solution. Then we use the first boundary condition, u of 0 t equal to 0, that is u equal to 0 when x equal to 0. And this term cannot be 0, else we'll get 0 solution. Therefore, by default, c1 equal to 0. So c1 is removed from the equation number 5, and we got the equation number 6. It is like this. Then we use the velocity condition. For that, it is required to find the derivative. We obtain derivative, and then we substituted t equal to 0 and del u by del t equal to 0.
तर ते इक्वेशन 6 मध्ये c2 sin mx कसं काय आलं?
अरे इथं पुट केलं ना, c1 equal to 0 ना, that I substituted. Substituting c1 equal to 0 in equation number 5. c1 equal to 0 means this whole term will be 0 ना. दिसते ना?
हाँ सर.
Okay, so what will remain? c2 sin mx and this term that I have written here. Okay.
Okay.
So when we started, equation number 5 was the solution, right? After using the first boundary condition, we obtained c1 equal to 0. That substituted in equation number 5. So now what is general solution? Equation number 6. Okay. Now you don't have to think about the equation number 5. Samajla? Understood? Now we use the velocity condition. And we obtained that we got this equation: c2 cannot be 0, else we'll get 0 solution, that you can observe from equation number 6. Then sin mx cannot be 0, then we'll get 0 solution from equation number 6. C cannot be 0, differential equation will change. M cannot be 0, general solution will change. Okay. Therefore, who should be 0? C4 should be 0. If C4 is 0, we don't have any problem. That we understood. Okay. So we substituted C4 equal to 0 in equation number 6. Not in 5, in equation number 6. Then we got this solution. So we modified it. And now equation number 7 is the most general solution for us. And now we have only two challenges. We want to find M, we want to find C5. Okay. So now we use till we use two conditions, one boundary condition and one velocity condition. Okay. Now we'll use the second boundary condition. So second boundary condition is used. U of LT equal to 0. That is when X equal to L, U equal to 0. Other end fixed. Meaning is other end fixed. So from there we got sin ML equal to 0. But we know that sin N pi equal to 0. So these two are compared. So ML equal to N pi. Now question may be, can we obtain L from here? No, not required. L is the length of string, that is fixed. It fixed hai, constant hai. So we obtain M equal to N pi divided by L. What the N is? 1, 2, 3, 4, 5. So M has infinite number of values. When N equal to 1, first value, N equal to 2, second value, N equal to 100, 100th value, and so on. So this M is substituted in previous solution, that is equation number 7. Here it is substituted. Here mx and c m pi l is there, na? So we substituted m here. So we got this solution. But again, the solution u of xt at this moment depends upon n. When n equal to 1 will get the first solution, n equal to 2 will get the second solution, n equal to 3 will get the third solution. Samjhun gaya, huh? N equal to 100 will get the 100th solution, n equal to 1000 will get the 1000th solution. Now question is, which solution should we consider? Whether we should consider u1, u2, u10, u1000, u billion. Okay, so what we have to do, mathematically we have to consider combination of all this. That is u of xt equal to u1 plus u2 plus u3. That is u of xt equal to, that I have written on the next page, u of xt equal to summation. Instead of c5 only pn is written. That is the only change, right? Sin of n pi x divided by l, cos of n pi ct divided by l. Then we have to use the last condition known as functional condition. And that is u of x0 equal to a sin pi x divided by l. So when t equal to 0, u is a sin pi x divided by l. That we have done in next step. Cos of 0 is 1. So we got this relation. Then this is expanded. We know it very well. Then the terms on both the side are compared. And we got b1 equal to a, b2 equal to 0, b3 equal to 0, b100 equal to 0, and so on. And they are substituted in the previous equation. That is equation number 8. Okay, so equation number 8 is written. Here it is. Then it is expanded. B1 is substituted. B2 equal to 0. So second term 0, third term 0, remaining all the terms are 0. And this is the solution. Understood now? आता समजलंय? काहीतरी बोला? Yes or no? कैसे बोलते? क्या नाराज है क्या आप? मैथ्स के ऊपर नाराज है या मेरे ऊपर नाराज है? You are not happy? I am not audible.
Audible, sir.
Audible, sir.
मग काय झाले काय? आवडे ना काय मॅथ्स? Right. Tightly, right? Tightly stretched string with fixed endpoints x equal to 0 and x equal to L is initially in a position given by u of x0 equal to u naught sine cube pi x divided by L. If it is released from rest means what is velocity? 0. from this position find displacement u at any time t. At any distance x from one end. This is the string. Say this is the initial position. This is x equal to 0. This is x equal to L. Sure, write with me. One dimensional wave equation is getting initial condition, initial position Chalo, let me go to the next page.
Sir, 1 minute.
Right. Written? चला चेंज करूँ क्या?
Yes, sir.
Most general solution is start with the x equal to 0 implies u equal to 0. Substitute. C1. Conclusion, who is 0? अच्छा आधीच केलं काय 0 पुन्हा नाही केलं. Who is 0 so that there will be no any problem. If the second term is 0, C3 cos of CMT plus C4 sin of CMT equal to 0, then we'll have a 0 solution. That we don't want. C1 equal to 0. This is general solution at this moment. We'll modify it. I'll use this, huh? But for that, what is required? Partial derivative is required. I'll obtain that. Differentiating partially with respect to
Sir,
t. हाँ बोला ना.
page
अरे यार हेल काय झालं? कुठं आलो आपण? 12 वर आलो. अच्छा इथेच राहिलं. ठीक आहे. चला योग्य वेळ सांगितलंस. थँक यू. हा. So I think I had to repeat this part. त्याला कंटाळा आला काय? Sorry. Let me start with the equation number 6 again. So we were at this point. Okay, so differentiating partially. X is constant. Now derivative. t equal to 0. बरोबर आहे का? Yes. Can anyone tell me who should be 0 now? C2 equal to 0, sin mx equal to 0, C equal to 0, m equal to 0, or C4 equal to 0. Who is 0? If you have any doubt, let me know. Huh? This is solution at this moment. Now we use the next condition. Understood up to this stage? Yes.
थर्ड लास्ट लाईन आहे ना, त्याच्यात जे स्क्वेअर ब्रॅकेट मध्ये काय लिहिलंय, C3 cos CMT आहे का?
हो. C3 cos of CMT. Return up to equation number 7. Okay, next. Use next boundary condition. U equal to L, sorry, X equal to L, U equal to 0. Right, so we obtain M, N pi divided by L. So on next page, we'll substitute M in equation number 7. Can I change the page? Can I change? Yes. Can I change the page?
Yes, sir.
तर तिथे लास्टला कॉस CMT का नाही घेतलं?
हा, हे बघा, एक असतं कन्सेप्ट जनरल टर्म आणि एक असतं स्पेसिफिक टर्म. ओके, सो ओके, एकच मिनिट. हे पहा, हे कॉस ऑफ सीएमटी आहे, दिसते. आणि इक्वेशन नंबर 7 मध्ये कॉस ऑफ सीएमटी आहे. सेम आहे का डिफरंट आहे?
सेम.
व्हेरी गुड. ओके, आता साइन ऑफ एम एक्स आहे इथं आणि तो साइन ऑफ एम एल आहे. सेम आहे का डिफरंट आहे?
डिफरंट.
हा, हे एम एक्स, हियर वी हॅव एम एक्स ना, दिस इज जनरल टर्म, मीन्स आय कॅन टेक एनी व्हॅल्यू ऑफ एक्स. कळलं? whereas sin of ml, now I cannot change x na, already we took x as l. Okay, so a particular term is 0, therefore the particular term is taken. Whereas if I take, suppose I take cos of cmt equal to 0, so I'll get 0 solution from equation number 7. But sin of mn equal to 0, does it mean that sin mx equal to 0? No, sin ml is a single term, sin mx is a general term. General means many terms are there. जेते की नाही? अरे इथं आपण,
परत सांगा.
हा, इथं x ची आपण एकच व्हॅल्यू घेतली ना, बरोबर. आणि वी आर सेइंग दॅट फॉर दॅट व्हॅल्यू ऑफ x दिस इज 0. बट सपोज आय टेक x इक्वल टू l by 2, डज इट मीन दॅट साइन m l by 2 इज 0? डोंट नो. नाही कळलं? एवढं लक्षात ठेवा, जी सेम टर्म असते ती घ्यायची नाही. ही सेम आहे, घ्यायची नाही. ठीक आहे, जी डिफरंट आहे ती घ्यायची.
ओके सर.
ही डिफरंट आहे, हे दोन्ही डिफरंट आहेत, म्हणून डिफरंट जी आहे ती घ्यायची. ठीक आहे, रिमेंबर इन दिस वे. ओके, as the n change, we'll get different solutions. I'll mention that. For different values of n, we have different u of xt, or different solutions combining all above un xt's. It. Last condition is remaining. What is the condition? U of Okay, now you might have understood. Okay, right up to this step. Fast. Can I continue? Any doubt till this step? Okay, let me continue. See what I want to say. See, on the left side, summation is there. So if I take n equal to 1, I'll get sine pi x divided by L. N equal to sine 2 pi x divided by L. N equal to 3 sine 3 pi x divided by L. But anyhow, I will not able to get sine cube. Na? We have sine cube on the left side, whereas we don't have sine cube on the right side. Okay. So we have to use this formula. Okay. So I'll use the formula. Understand why I am using the formula? So using what is sine cube theta written before some time. Okay, therefore what is sine cube pi x divided by L? That will be 3 by 4 sine pi x divided by L minus 1 by 4 sine 3 pi x divided by L. చెప్తే నా? So I'll write it here. इथे लिहिणार आहे मी आता next step मध्ये. Okay, and then I'll expand the right side. Let me do that on the next page. Can I go to the next page? Understood what we are doing? We should be able to compare the terms on both sides. Then only we'll able to find b1, b2, b3. Isn't it? Say yes.
Yes, sir.
Okay, let me change the page. Chala. So I'm writing the term on right side. 3 by 4 sine u naught is there outside. That also I have written pi x divided by n minus u naught by 4 sine of 3 pi x divided by n equal to summation. I'll expand the summation now. Okay, summation is like this. Let me write it by black color. B1 sine of pi x divided by n equal to 2. B2 sine of pi x divided by n. B3 either 2 8 sine of 3 pi x divided by L. B4 B5 B6 जेते सराउंड आहे comparing terms on both sides. These two terms are same. Right? There is no any B2 term. These two terms are same. Minus u naught divided by 4. What about B4? 0. B5? 0. And so on. Remaining all B's are equal to 0. झेपते एवढं कितना समझ में आ रहा है आपको?
Yes, sir.
Okay. Now what we have to do? We have to substitute these B1, B2, B3, Bn in equation number 8. That's it. It is like this. expand it. And remaining all are equal to 0. Therefore, that's it. This is the solution. Any doubt here? आता काय doubt आहे सांगा? कुछ डाउट है अभी? अभी थोड़ा सा कॉन्फिडेंस लग रहा है?
Yes, sir.
Can we go to the next example? और एक solve करते हैं and then for today we'll stop.